Hi students, it's Ms. Vernon, and I'm here today to kind of break down our lesson, our exploration you did on power functions from yesterday. So today I'm going to really concretely decipher what hopefully you started to see in patterns in our exploration. And your goal today is to be able to differentiate between the different shapes of power functions and be able to graph those same power functions given an equation, but not having to rely on your calculator. So the first thing I want to talk about is that in our work yesterday, we definitely talked about the different quadrants, and I want to just start off by reviewing our quadrants of our coordinate plane. So quadrant 1 is the first quadrant, which is the positive values, and then we move counterclockwise around the graph. So that's 2, 3, and 4. We will be referring to the different quadrants as we go through our lesson today. So next, what we're going to do is we're going to break down the 3 big takeaways you hopefully got from yesterday's lesson. The first thing we're going to look at is the general shape the graph will take. I usually tell students to save the shape of the graph for the last thing they find. But we're going to go ahead and start off with that because it's something that will help us make connections to our exploration yesterday. So the first shape our graph can take is a linear equation. This happens very infrequently, but it can happen, and that occurs when A equals 1. Okay. The second shape our graph can take, and I'm going to grab our highlighter for this, is it could take the shape of this kind of U shape or half U shape. I'm highlighting it in yellow. This will occur when the A value is greater than 1. Examples of this would be x squared or x to the third. Those are really common examples that we know of the graph. And so that's going to be that like U-shaped graph that you see there. The third type of shape our graphs can take is this green one. And you might recognize this green curve as our rational or 1 over x function. And the rational function will occur anytime the exponent is less than 0. So with this one, a really great example would be like 1 over x. And now you might say, well, Ms. Vernon, that's not a negative exponent. But remember, it's also not written in a power function format. So to write it as a power function, we need to move the variable from the denominator to the numerator and make that exponent negative. Now you can see the exponent is negative and therefore verifying that curved graph. The fourth and final shape our graph can take is this kind of slow hill or slow climb graph. And that occurs when our exponent is between 0 and 1. Common equations for this would be the square root of x, which when rewritten as a power function is x to the 1/2, or maybe the cubed root of x, which again written as a power function would be 1 over 3. Recall that we can rewrite a radical as a rational exponent by writing the power over whatever your number is inside of the radical, and that will give us our rational exponent. All right, now that we have the 4 general shapes the graph can take, we're going to talk about a key point that will determine whether or not the graph will exist in quadrant 1 or 4. And so all of these power functions will start in the format of y equals kx to the a, to the power of a. Now, whatever the k value is, that's going to determine whether or not we end up in quadrant 1 or quadrant 4. If k is positive, we're going to end up in quadrant 1, k positive. If the k value is negative, we're going to end up in quadrant 4. Now, we will always pass through the point 1 comma k with a power function. So we go over 1, and then whatever k is, we either go up or down, and that's going to signify whether or not we're in quadrant 1 or 4. The third component of figuring out the graph of a power function is based on the exponent or the value of a. Now, formally, we define this as if the x or base, whatever we plug in, is greater than 0, then these are the things that happen. So the first situation that can happen is that we call it f, or the function is undefined. And this occurs when the number in the denominator of the fractional exponent is even. So if that number in the denominator is even, so the denominator of exponent is even, then we say it is undefined. What this means is the graph will only exist in quadrant 1 or 4. It doesn't exist anywhere else. The reason this occurs is because you can't take an even root of a negative number. So for example, you can't take the square root of negative 25. Well, you can, but it's imaginary, so we can't actually take it. It doesn't exist. Therefore, we don't graph it because we can't see it. The next situation that can happen is we can have what we call an even function. There are a lot of ways to get an even function. An even function is when the numerator ends up being even, but the denominator is odd. So negative 2 over 1 or 2 over 3. These types of functions will be symmetric with the y-axis. So you're going to see that butterfly symmetry. Remember, we've talked about butterfly symmetry earlier this year. And this butterfly symmetry just means that it's going to be in the quadrant next to whatever quadrant it was in initially. So if it was in quadrant 1, we also end up in quadrant 2. If we're in quadrant 4, we also end up in quadrant 3. So even functions are going to have even symmetry or symmetric about the y-axis. And you probably guessed it, we also can have what's called an odd function. An odd function, if you recall, is symmetric about the origin, which means it has rotational symmetry. An odd function will occur if the exponent ends up being an odd number over an odd number. All right, let's go ahead and take a look at how I typically recommend students process these. So the first step, anytime you're analyzing a power function, is to write it in the power function format. They may give us different formats of these functions, and we may need to rewrite them. I can give you some examples at the end of this, what that would look like. After you've written it as a power function, it'll be much easier to follow these steps. So step 1 will be to determine whether or not the graph will be in quadrant 1 or in quadrant 4. Again, this is determined by the k value that is in front of the x term. Plot the point that you get, so 1 comma k. Step 2 is analyze the exponent. The exponent is going to help us determine if the graph will exist in a quadrant other than the given. So recall, if it is an even number over an odd number, then we have an even function. This means that the graph will either be in quadrants 1 and 2, or the graph will be in quadrants 3 and 4. We can have an odd function. An odd function will be in opposite quadrants or diagonal quadrants, so quadrants 1 and 3, or they could be in quadrants 2 and 4. So 1 and 3 or 2 and 4. Last, we can have an undefined graph. Remember, an undefined graph is when the denominator of the exponent is even. All this means is it is only going to exist in one quadrant. So it will only be in quadrant 1 or it will be in quadrant 4. but it won't be in any other quadrant besides that. The third step to figuring out the graph is to figure out the shape of the graph. Now I'm going to assume that K is positive, so I'm going to just sketch these. So anytime the exponent is between 0 and 1, we end up with that hill-shaped graph. This would be if you have like the square root of x, which is x to the 1/2 power. Again, that would be an example. Next, if a is less than 0, this is going to be your rational function. So it'll be your curved graph that kind of has those asymptotic behaviors. This would be if you had the 1 over x, which is rewritten as x to the -1. Lastly, if a is greater than 1, you end up going from the origin up and having that kind of curved graph. Again, this would be like x to the 3rd or x to the 4th, any of those where you have that curved shaped graph. Now again, we can have a linear function, but then the exponent is 1, and most of us would not have trouble graphing that. All right, let's move on to some examples. All right, so I have 3 examples for us today. The first example is here, and you're going to graph this by hand. And so here is our function. I always encourage you to check, is it in power? Is it a power function? And it is. We have our k value equaling 2 and our exponent equaling 3. Anytime it's a whole number, I like to write it as a fraction just for analyzing it later on. So step 1, determine your point it will pass through. In this case, it's going to pass through the point 1, 2. So I'm going to graph that right away so that I get that plotted. This automatically tells me we're in quadrant 1, which means we're not going to be in quadrant 4. Next, I'm going to look at the power. In this case, our power, or a value, is 3 over 1. Because this is an odd number over an odd number, it tells me it's an odd function, and it will exist in another quadrant. In this case, it is also going to exist in quadrant 3 because odd exponents, or an odd function, has opposite quadrants, so diagonal quadrants. So 1 and 3. Last, I need to determine the shape of the graph. Now, because our a value is greater than 1, I know it's going to behave like our quadratic or cubic graph. So it's going to be that U-shaped or half U-shaped function. So I'm going to go ahead and plot that. Because I also know it existed in quadrant 3, I can plot the point -1, -2, just to give me a little bit more precision. And there you have a sketch of our cubic function. Okay. Questions so far? All right, let's move on to another example. Here's an example where our initial graph is not written, or our initial function is not written as a power function. We're going to have to do a little bit of work before we can even start to analyze it. So when I start to do this work, I recognize that I'm taking the cubed root of 8x. So I'm going to take the cubed root of 8, and I'm going to take the cubed root of x separately. This is going to help me identify the a value, or the k value up front, as well as the a value. The cubed root of 8 is 2, and the cubed root of x is x to the 1/3 power. Recall, we can write any radical as a rational exponent or fractional exponent. So moving forward, I'm going to use this as the power function I analyze. Next, I'm going to follow the 3-step process that we just practiced. Step 1, what point must our graph go through? In this case, it must go through the point 1, 2, so therefore it exists in quadrant 1. I'm going to plot that point right away. Step 2, it's time to analyze the exponent. In this case, our a value or exponent is going to be 1/3. The first thing I check for is this function odd, even, or undefined? Because the denominator is an odd number, it is not undefined. Next, I check the numerator. Because it is odd, I know this is an odd function. Therefore, it will also exist in quadrant 3. Remember, odd functions have rotational symmetry, so they will exist in diagonal quadrants. Next, we're going to look at the exponent again and recognize that our exponent is between 0 and 1. This implies it's going to be the hill shape or the gradual incline. So I can now graph what I know. I know the shape, and I know that it exists in quadrant 1 as well in quadrant 3. So I'm going to plot the point -1, -2. Again, reflecting that same shape, I see that I have an odd function that is graphed in quadrants 1 and 2, passing through the point 1, 2. Okay, great job so far. We've got one more example to do together. Again, we're asking you to describe how to obtain the graph of this function and sketch it by hand. So as I look at my function, I see that this is not written in power function format. I see that the denominator of this function needs to be moved from the denominator to the numerator. To do this, I'm going to make the exponent negative. So I now have a power function, -1x to the -2. Now I'm ready to start to analyze. Moving forward, I'm going to use this as what I'm analyzing for my process. Step 1, figure out the point it will pass through. In this case, it passes through the point 1, -1. This is going to place my function in quadrant 4. Next, identify the power and if it's even, odd, or undefined. In this case, my power is -2/1. First, I check if it's undefined. Because the denominator of this fraction is odd, it is not undefined. Next, I look at the numerator and I see that it's even. Therefore, this is going to be an even graph or have even symmetry. That means that if my function exists in quadrant 4, it's also going to exist next to it in quadrant 3. I can plot that extra point now, or I can plot it later when I go to graph it. Last, I need to determine the shape of my function. In this case, my power is going to be less than 0. Therefore, it's going to be that rational function curve, the one that has the asymptote in between. Now, sometimes students get confused when we reflect it, but if that's what it looks like in quadrant 1, it's going to just be flipped over the x-axis in quadrant 4. So graphing this, again, you want to do that quick visual check. Do I have butterfly symmetry? Pretty close. My picture's not perfect, but it's doing a good job of giving the shape and correct location. I hope this explanation of power functions, how to recognize key features, is helpful in understanding the concept today. We'll see you soon. Bye.